Okay, so now we're going to look at converting decimal to binary. And we're going to do it two different ways. We're going to use the division method and the subtraction method. In practice, almost everybody I know uses the subtraction method, but I want to show you both ways in case you encounter them out there. So let's start with 56. What we're going to do with the division method is we're going to keep dividing by 0 until we have, by 2 until we have nothing left. Once we have nothing left, then we know we're done. And we're going to be looking at the remainder every time we divide by 2. Now, if you have a remainder when dividing by 2, it's always either going to be 0 if it's an even number or 2 if it's an odd number. Those are the only possibilities. So 56 divided by 2 is going to be 28. And it has a remainder of 0. So I'm just going to write 0 over here in this column, and that's where we're writing our actual final binary result. And because we have 28 left over, that comes down. (28) divided by 2 is 14. And again, it's got a remainder of 0. So we're just going to write a big 0 over there. And then the 14 comes down. (14) divided by 2 is 7. With a remainder of 0. So I'm going to write a 0 over here. And again, I'm going to stop drawing those lines. The 7 comes down. 7 divided by 2 is going to be 3. And now we have a remainder of 1. So I'm going to write a 1 over here. And now the 3 comes down. 3 divided by 2 is 1, right? 2 goes into 3 one time with a remainder of 1. So I'm going to write a 1 over here. The 1 comes down. 1 divided by 2 is 0 with a remainder of 1. So I'm going to put a 1 over here. So then our number is counterclockwise. It is 1, 1, 1, 0, 0, 0. Now, how do we know that that's the correct number? If your answer is because we can convert it back to decimal. So let's go ahead and draw our chart. We draw the powers of 2. We draw the values of the powers of 2. Cross out the zeros and add up what's left, right? So 32 plus 8 is 40, plus 16 is 56. So that is correct, and we were able to use the division method to successfully convert a decimal number to a binary number. So how do you do the division method again? You take a number, you divide it by 2 each time, you take the remainder, write it off to the right-hand side, you take whatever's left, the dividend, and bring that down, and you keep dividing until the dividend is 0. Then you know you're done. Okay, let's do this. Let me go ahead and do the subtraction method. Now, the subtraction method requires us finding the largest power of 2 that is still less than whatever number we're trying to figure out. So it's actually very helpful to write out your powers of 2 ahead of time until you memorize them. And I'll tell you, to this day, if I take a certification exam and they give me one of those little laminate pieces of paper, first thing I do is write out the powers of 2 on the top. So our powers of 2 are 0, 1, actually we can ignore 0. 1, 2, 4, Okay, so this is up to 2 to the 10, which is about as high as you're ever going to need to know it. But these are our powers of 2. So again, let's take the number 56. Now in this method, we're going to keep subtracting the powers of 2 until we have 0. So we can't subtract any of these because that's already larger than our number. So we're going to start with 32. So 56 minus 32. Every time we can subtract it, we write a 1 over here. Okay? 56 minus 32 gives us 24. The next power of 2 is 32. Oh, excuse me, 16. Can 24 subtract 16 and still be positive? It can, so we're going to write a 1 over here. 24 minus 16 is 8, right? The next power of 2, coincidentally, is 8. Can 8 subtract 8 and still not be negative? And the answer is yes, so we're going to write another 1 over here. But obviously 8 minus 8 is 0. The next power of 2 is 4. Can 0 subtract 4 and be positive? It cannot. So I'm going to write a 0 over here, and this 0 comes down. And obviously it's just going to be 0 all the way through, but we're just going to keep doing that. Can this subtract 2 and still be positive? It cannot, so I'm going to write a 0 over here. And can that subtract 1 and still be positive? It cannot, so I'm going to write a 0 over there, right? So our number, now this one rotates the other way. It rotates counterclockwise. So this is 111000, right? That is, and we already checked that, that is the correct answer. So those are two different ways of converting decimal to binary, the subtraction method and the division method. You should practice both of them. And it's pretty easy to do. Get out a piece of paper, pick a few numbers, convert them, and check it in your calculator. If you have any questions, let me know.